Simultaneous equations with a quadratic. We are going to solve these kinds of equations. We are going to solve them algebraically, and we are going to solve them graphically. So let us start first with algebraic method. X squared plus y squared equals 5. You know that this is equation of a circle of center 0, 0, which is the origin of the coordinate plane, and y equals 3x plus 1 is the equation of the line. Then we need to solve them algebraically. Since we have here y in terms of x, we take the value of y and replace it in the first equation. So we get x squared plus 3x plus 1 squared equals to 5. Now we need to expand this. This is of the form a plus b squared, which is equal to a squared plus 2ab plus b squared. So 3x plus 1 squared is equal to square the first and square the second. You put it at the end, and in the middle it's 2 times the first times the second, which is equal to 6x. Now this is the value, 9x squared, we write it here, plus 6x plus 1 equals 5, and we don't forget the x squared from the above equation. Now we collect like terms. It's 10x squared plus 6x, and we take the 5 to the other side. It becomes minus 4, because plus 1 minus 5 is minus 4, equal to 0. Now here we can see that we have a common divisor, which is 2, so you divide everything by 2. So we get 5x squared plus 3x minus 2 equals 0, and this is the form of a quadratic. This is a form of a quadratic equation. In order for us to solve this quadratic equation, we need to factorize. We have the 5 here, so we write 5x and 1x, because 1 times 5 is 5. And we have a 2 here, so it is 2 and 1. The factors of 2 are 2 times 1 gives you 2. Now we need here to have a minus, therefore one of them is going to be minus, one of them is going to be plus, because when you multiply minus 2 times plus 1, it gives you minus 2. Now we have to check if the middle one is right, or if our factorization gives us the middle term. So you start multiplying 5 times 5x times 1, it's 5x, and minus 2 times x is minus 2x, which is, it gives you plus 3x, which is right. So the way that you've stated the factors here, it's right. This is equal to 0. So 1 time x, 5x minus 2 is 0, or x plus 1 is 0. So when 5x minus 2 is 0, then x is equal to 2 over 5. And when x plus 1 is 0, x is equal to minus 1. Now for this x you have a y, and for this x you have a y. So you place it in the equation, in the second equation. So y is equal to 3 times 2 over 5 plus 1. So y is equal to 2, 1 over 5, or y is equal to 3 times minus 1 plus 1. So this is equal to minus 3 plus 1 is minus 2. So when x is 2 over 5, you have the y 2 1 over 5, and when x is minus 1, y is minus 2. So these two are the solution for the equation that form the system, and they are the solution for the system. They satisfy these two equations at the same time. Now let us solve it graphically. We know that x squared plus y squared equals 5 is our first equation, and this is the equation of a circle of center 0 0, which is the origin, and the radius is square root 5, because 5 represents r squared, so r is represented by square root 5, and square root 5 is about 2.25. So you put your needle on the center, and then you open your compass at 2.25 and you draw your circle. This is the first equation. So the circle represents the first equation. Second equation is represented by a line. So we have to use the table of intercepts. When x is 0, y is 1, and when y is 0, x is minus 1 over 3. So this is when x is 0, and minus 1 over 3 is somewhere here for x. You draw your line, and this is your line that represents the second equation. Now look at the points of intersection. This is the first point of intersection, and this is the second point of intersection, so we have two solutions. Comparing it with the algebraic solution that we found, we have also two solutions. If you look at minus 1 for x and minus 2 for y, you get this point, which is this one. And if you look at 2 over 5, which is somewhere here, with 2 and 1 over 5 is somewhere here, so this is the second solution. So we have actually here solved these two simultaneous equations in both methods, in the algebraic method using algebra and the graphical method using the graph.